Instructions of 8085 Microprocessor Part 1. In the very beginning of this chapter, I told you that in this chapter we are going to cover the different groups of instructions, starting with data transfer group of instructions, thereafter arithmetic group of instructions, and finally the logical group of instructions. So as planned, we started our journey of learning the different instruction types of the data transfer group of instructions. However, we took a detour. If you remember, we studied about the register codes, formation of opcodes, and in the previous session, we learned about the different addressing modes. Well, that was necessary. And the reason for that is, we have learned so many instruction types of data transfer group of instructions so far, but it was a bit unclear that which instruction type falls under which addressing modes. Anyway, from this session onwards, we will resume our journey of learning the data transfer group of instructions. Well, to be precise, whatever is remaining of that. So in this session, we are going to learn about the instruction types LDAX RP and STAX RP. So without any further ado, let's get to learning. Coming to the topics that we are going to cover in this session, today, at first we will learn about the instruction type LDAX RP, and thereafter we will learn about the instruction type STAX RP. So let's begin with the first instruction type, that is LDAX RP. Now coming to the instruction type LDAX RP, I think you can make some assumptions. In the instruction type, if you focus on the mnemonic, this stands for load accumulator from memory pointed by the extended register. Now what is meant by extended register? I hope you remember, extended registers are nothing but the register pairs. So we will have the programmer's view. Now since the accumulator is to be loaded from the memory, which will be pointed by the extended register, so we also need the memory for the illustration. And remember, we are talking about the extended registers or the register pairs, so one can assume that we are talking about these pairs. That is, the register pairs formed by the general purpose registers. Let's now decode the instruction. Notice, in the mnemonic it is said, load accumulator from memory pointed by the extended register. Now focus on the instruction. LDAX RP. We are about to mention the first name of a register pair, or to be precise, B in case of BC. In the earlier sessions, I already have told you what is the reason for that. When we are considering BC as a register pair, C becomes the extension of B. And that's the reason why at this place only B will be mentioned. Now think about it. We are trying to communicate with the memory, however, in the instruction, we are not mentioning the memory. So clearly, it falls into the category of register indirect addressing mode. Isn't it? Now I hope you remember what is the register indirect addressing mode. In there, we use the register pair using which we are actually addressing the memory indirectly. Now before we move ahead and observe the illustration, I would like to mention this. The instruction of this particular type are of 1 byte long. And if you notice, that too is justified. LDAX, and after that we will have the register pair's name, or to be precise, the name of the first register, where the rest of the part will be an extension only. So this entire instruction type can definitely fall under the category of 1 byte long instructions. Now allow me to illustrate how this instruction will work. Say we want the microprocessor to execute this instruction. Now what does this instruction mean? LDAX B. Remember, we are talking about the BC register pair this time. Now let's suppose within the memory location F820, there is a data 12. And we want that to be loaded inside the accumulator. Now for this, within the BC register pair, the address, that is F820, will have to be loaded at first. This will specify that the memory location F820 is currently being pointed by the BC register pair's content. Notice, C has become the extension of B. Now if the microprocessor executes this instruction, that is LDAX B, load the accumulator with the value inside the location which has been pointed by the BC register pair, the data will then be loaded inside the accumulator register. Let me show you another example. Say we would like to execute the instruction LDAXD. So this time we will be talking about a memory location which will be pointed by the D register pair. Now let's suppose at the location F821 we have got the value 34. Now if we want this value to be loaded in the accumulator register by executing this instruction within the D register, at first we will have to load the address of the memory location F821. So let's do that. Now once this is done, this will mean that the D register pair is now pointing to this particular memory location. Now if the microprocessor executes the instruction LDAXD, the value within the memory location F821, that is 34, will then be loaded inside the accumulator register. So this is how these two instructions will work. Now for the instruction type LDAXRP, what do you think will be the next instruction? Well, general presumption would be LDAXH. But let me tell you, there is no such instruction in 8085. That is, the HL pair is not used in this manner. Now you might be wondering, we have the instructions for LDAXB and LDAXD. Why not LDAXH? In order to explain this, I would like to take you back to the instruction MOVR, I hope you remember this. MOVR, specifies that we are supposed to load a register with 8-bit value in the memory location. And what is the memory location? The memory location which is pointed by the HL register pair. This too is an example of register indirect addressing. And if you notice, using this instruction, we can perform the same which we could have performed using LDAXH. So, since this instruction already exists, there is no use of having another instruction of the same functionality. So do remember, of the instruction type LDAXRP, there are two opcodes or two specific instructions, LDAXB and LDAXD. And both of them mean we are supposed to load the accumulator pointed by the extended registers. However, in order to execute this, we need to load the register pairs with the memory location at first. Another thing to notice in here, we don't have instruction like LDBXRP or LDCXRP. And the reason is quite simple, because accumulator is the special purpose register which has different ways to address this. I hope you remembered that from the previous session. So that was all about the instruction type LDAXRP. Do remember, this occupies only 1 byte space in the memory. Let's now learn about the next instruction type, STAXRP. Coming to the instruction STAXRP, I think you already have presumed what it means. Well, the mnemonic of this instruction type means we are supposed to store the accumulator contents in the memory which will be pointed by the extended register, or in other words, the register pair. So we are talking about the register pairs, and for that we will also need the memory, because the content within the accumulator is now to be stored within the memory locations. Now if we notice the instruction type, just like the previous one, here also we are not talking about the memory location. Rather, within the instruction we are going to mention the register pair. So this is also clearly a register indirect addressing. Now STAX-RP instruction type, just like the previous one, that is LDAX-RP, falls under the category of 1 byte long instructions. Now the opcode for STAX-B will help the microprocessor store the accumulator content into the memory location which will be pointed by the BC register pair. And the same thing can be said for the instruction STAX-D. However, using this instruction, we will be loading the content of the accumulator in the memory location which is going to be pointed by the DE register pair. In these two cases also, before we execute the instructions, within the pair, we will have to load the intended memory location. Now what about STAX-H? Just like LDAX-H, we also don't have any such instruction in 8085 microprocessor. And the reason is also quite similar. We already have the instruction MOV M,A. Notice, this is the opposite of the previous instruction that we had. In the previous instruction, instead of LDAX-H, we had MOV A,M. This time, MOV M,A will work as same as STAX-H would have. That is, using this instruction, we can also store the contents within the accumulator register into the memory location which is going to be pointed by the HL register pair. And that's the reason why we don't have STAX-H instruction in 8085 microprocessor. So do remember, in case of STAX-RP, we have two opcodes, one for STAX-B, another one for STAX-D. And both of them fall under the category of 1 byte long instructions. So that was all about the instruction type STAX-RP. Remember, STAX stands for Store Accumulator Contents in Memory pointed by Extended Register, that is the register pair. So in this session we covered the topics, the instruction type LDAX-RP and the instruction type STAX-RP. The first one loads the accumulator with the contents within the memory which will be pointed by the register pair. On the other hand, the second instruction, that is STAX-RP, it stores the content of the accumulator within the memory location pointed by the register pair. Alright people, that will be all for this session. In the next session, we are going to learn about 2 more instructions of the data transfer instruction group. So I hope to see you in the next one.